Hello, this is Dr. Mears, and today we're going to be learning about piecewise functions and do a little domain and range application. So piecewise functions, they're really fun. They look intimidating. Please do not be intimidated by it. It's really just going to pick the function that fits. So let's get into it. A function that has, what is a piecewise function? It's a function that has two or more equations for different intervals of the domain of the function. So let's look at what a piecewise function is. F of x equals, so here's the thing, f of x could equal 2x, f of x could equal 4, f of x could equal 1/2 x plus 2. So it's like we have three different equations here. Well, we actually do have three different equations, but there's certain intervals that they only work for. Let's see what I mean by that. We have to find f of 2, f of 3, and f of 7. There's three separate problems here. There's the f of 2, the f of 3, and the f of 7. So let's do f of 2 first. So they want us to put 2 into one of these f functions. So we have to go to these intervals to see where this number fits. So this is 2. This is the x. This is the domain. This is the domain. This is the x. These are all x's here. Okay? So we have an x of 2. So it equals 2. So which one can we have an x of 2? Well, here it says 0 is less than or equal to x, which is less than or equal to 2. So this is the function that we choose. So we're going to use the function f of x equals 2x. Because this 2 fits in this domain, we have to find which one it matches up with. It matches up with this one, so we're going to be using the 2x. So what do? We put 2 in for x. So f of 2 equals 2 times 2. So f of 2 equals 4. So we have this x of 2. We found that it matches in this domain. We used this equation, substituted it in, and found that it's 4. Well, let's try the next one. F of 3, right here. F of 3. So now that we have an x of 3, we have to go, this is the first thing, number 1. Go and find which domain it fits. Find what fits. So we have 3. So which one does that fit into? We have between 0 and 2. Okay, 3 is not between 0 and 2, including 2. Is 3 between 2 and 4? It is. This really means 2 is less than or equal to x, which is less than or equal to 4. So any number between 2 and 4, including 4, you use this one. So we do have 3. It fits in this second one. So we're going to use the f of x. F of x equals 4. If we put the 3 in for the x, what are we going to get out? We're going to get out 4. No matter what you put in for x here, we're always going to get out 4. All right, let's try the next one, f of 7. So f of 7. So find what fits. And then number 2, we find the equation to use. All right, so we have 7. Is 7 between 0 and 2, including 0 and 2? Nope. Is 7 in between 2 and 4? Nope. Is 7 in between 4 and 8? Yes. So this is 4 is less than x, which is less than or equal to 8. 7 is in between there. So we're going to use this one. So we're going to use f of x equals 1/2 x plus 2. What number are we putting in? We're putting in 7. So this is number 3. Substitute equals 1/2 times 7 plus 2. F of 7 equals 1/2 times 7 is 3.5 plus 2. I'm just doing this out. You could use your calculator, but I just wanted to show all my steps. So for this one, we look to see what number, we find what fits what domain. 2, we pick our equation, or we pick our equation. Whatever the domain is, matches up with the equation that we're going to be using. And number 3, we substitute it in and we actually get it. So if you have trouble reading these, please come and see me because that you have to know where the number fits into the interval. Okay, next, how do we sketch this? Sketch the graph. Well, we have a lot of pieces here. So let's take this one step at a time. First, let's do f of x equals the first one, 2x. And let's write down where it is, between 0 and 2, including 0 and 2. So let's graph this one. How do we graph this? Well, this is a y equals mx plus b. Mx plus, there's no b, so that's 0. And I'm just going to put a little comma to separate this. So what's b? 0, 0. That's our start point. Our m is 2, but we have to change it into a fraction, so we're going to make it over 1. The number on top is positive. That means we go up. The number in the denominator is positive. That means we go right. So we're going to start at 0, 0. Then we are going to go up 2, 1, 2, right 1. Up 2, 1, 2, right 1. Up 2, 1, 2, right 1. Oh, I have no numbers on this graph. I was counting by ones. So let's put some numbers on this graph. Let's also put some labels on this graph. My goodness, everybody, I just jumped into graphing. Negative numbers, positive numbers, all the numbers, and all right. There we go. Perfect. Now you can see we started at 0, 0. We went up 1, 2, right 1. Up 1, 2, right 1. Up 1, 2, right 1. Now here's the thing. We could go down 1, 2, and left 1. And that would give us some more points on the other side, and that should be. But this is where the domain comes in, okay? We can only have the graph. We can only have this line that starts at 0 and ends at positive 2. That's the only part we can show. So let me repeat that again. The only part we can show is the part that starts at 0 and ends at positive 2. So this point, this point, this point. So this line right here has to start at 0, and it can't go past positive 2. So that's the only part of the graph that they wanted. The reason why it's called piecewise is because we're graphing pieces. All right, let's graph our next piece. Our next piece is f of x equals 4. However, we're only going to have it between 2 and including 4, not including 2. But we can actually see that this is including 2, so there is actually going to be a dot on there from this guy. So these continue on. So the graph is going to look kind of funky. All right, f of x equals 4. So this is my f of x. I actually put a y. It's okay. Absolutely fine. So if you want to change it to f of x, that's fine. And so what we're going to do is we need a line through the f of x at 4. So here's 4, and we're going to draw a line. Now here's the thing. It can only be between 2 and stopping at 4, including 4. So at 2, so we need to erase this part. Erase that part, erase this part. Okay, so starting there. And it's going to go to 4. Erasing all of this. So it's just this little piece right here, everybody. Nothing else. That little piece from 2 to including 4, and that's why I put a point on it right there. That's it. Again, piecewise functions. Okay, and let's do the last one. The last one's f of x equals 1/2 x plus 2, and this is only between 4 and, we're going to have to add some numbers to the graph, 4 and 8. So I went to 6 here. I know, I'm sorry, everybody. Here's 7, and here's 8. My bad. My apologies. I didn't give you enough little dash marks, but we can extend the graph, everybody. Okay, so first, this is mx plus b. So we start at b, mx plus b. We start at b, 0, 2. And then what are we going to do? We're going to do our slope. Our slope is 1/2. 1 is positive, up. 2 is positive, right. So let's go to 0, 2. 0, 2 is here. And you know what? I'm actually going to get I'm going to get a pencil for this. Okay. So I'm starting at 0, 2. And then I'm going to be going up 1 over 1, 2. 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 And that should be the 8. Perfect. Now, where do I connect? 4 to 8. Here's 4. That was there was a point, but I'm actually using that point from 4. 4 to 8. 4, 5, 6, 7, 8. So I don't need this point, and I don't need this point. So look how funky our graph came out to be. This is piecewise. First, we had a piece of the 2x, f of x equals 2x. That was this one. That was this piece. Then we had a piece of the 4 right here, f of x equals 4. Then we had a piece of the f of x equals 1/2 x plus 2. There's that piece, and it stopped here. There's the bell. The bell always rings. So here's my graph of this piecewise function. I think it's pretty cool. I do. I like piecewise functions. I like to see what picture they make. So there you have it. Okay, last thing are our applications. Your application also came with calculator steps. These are going to be calculator steps to find zeros, which are the x-intercepts, and maximum or minimum if needed. If you would like to take a screenshot of this, I'm trying to get everything in. First, you need to put the equation into y equals and graph it. But then this is here's your screenshot for those of you who aren't in my class of how to find the zeros and the intercepts. You, of course, have to put in the equation. We are going to go through this, but let's read the example first. And, of course, the bell's going to ring again. My apologies. This is what happens when you videotape at school. Okay, example 2, this is our application problem. We're going to look at the path of a golf ball after being hit by a club can be modeled by the function h of t equals 60t minus 16.1t squared, where t is the time in seconds and h is the height of the ball in feet. So if we were going to do an ordered pair, it would be t comma h. Input domain is t. Height is range, which is output. All right, now that we have some information down, use your graphical display calculator, that's GDC, your calculator, to sketch a graph of the ball's path. Label the axes. So we know this from the sketch and draw. Actually, you know what? I'm not even going to draw the graph yet. Let's put it in our calculator. Here we go. Let's press that on button, on. We're going to press this y equals, and we're going to input the equation that we see. Remembering, we're going to be using this xt theta n button. So we're going to do 60, and then we have x. I know it's t here, but the calculator is going to make it x. Minus 16.1 x, and then we want it squared. What I'm going to do is I'm going to press zoom, and then I think I'm going to go with zoom 6 for standard. Let's see what that looks like. I might have to zoom out. Yep, look at that. So let me bring this up a little bit more. It's that blue, so let's zoom out. So I'm going to press zoom. Out is 3. Now remember, we have to press enter, and we should get the graph. Ooh, look at that. It goes all the way up and all the way down. So I'm just going to push this up arrow. Does everybody see that blinking dot when I push that up arrow? So I'm just going to push this up a little bit. I'm going to try to go all the way up. And then what happens? Let's see if I zoom out. Zoom 3. Enter. That's probably going to be zoomed out too much. Yeah. So it makes this upside down U here. You know what? Let's zoom back in. Zoom 2. We're just zooming in and out. We're having a little bit of fun with this graph. So moving that little dot, if I press that up, see that little dot? Moving this will help you to zoom in and zoom out where that blinking dot is, which is pretty cool. Like working a camera, you just put where you want to zoom in. If it was a phone, you would just touch here and then, make it bigger. There's the bell again. Yay. All right, so you know what? I'm satisfied with that picture. So that's what I'm going to draw here. This is X. Actually, this is our T, right? That's T, okay? And this is H of T. And kind of looks like it goes up here and then back down. Perfect. Overall shape of the graph, labeling the axes. And I labeled them correctly using what they gave me from the problem. If you make the mistake of doing X, Y, I probably will dock you a point the first time you do it. And then if you can continue to do it on your test, I only dock you that 1 point. All right. Part B, explain why this graph is a function. So if I take my pen and I do the vertical line test, my pen is only hitting 1 point at a time on this graph. So passes the vertical line test, VLT. And that's all you need to do. Just write that. Part C, use your graphical display calculator, your GDC, to find the t-intercepts and maximum value. Now your t-intercepts are also going to be are also your x-intercepts. Remember, mathematicians, we love to take the same concept and give it like 20 different names. So your x-intercepts are also known as your zeros. The reason why they're known as your zeros is because your t value is actually going to be a value, but your y will always be 0. Your h of t will also always be 0. So that's why they're also called zeros, and that's what they're going to be called on the calculator. So this is where you take out your calculator steps, because we need to find the zeros, which are the x-intercepts. We already put the equation and we graphed it, and now we may proceed to here. So we're going to take out our grapher and turn it on. First, we're going to be pressing second. Second is this blue button, second. And then this trace button. What we're really doing is we're pressing calc, which is calculate. This menu comes up and you're going to press the 2 for zeros. That's what we're going to want to find. Then we're going to choose one of the intercepts. I always choose this left one first, the one towards my left hand. So what we're going to do is on the bottom it says left bound. That means you have to be on the left side. So I am going to use my left arrow to go down. It went down, and I'm going to press enter. Now it says right bound. So what you want to do is you want to use your right arrow key to get the blinky dot on the right side of this intercept. And once we have enter, it says take a guess, and you said yes, please. And your first 0 is at 0, 0. And you can see that down here, 0, 0. Okay, so let's write that down. The first one is 0, 0. Writing that down. Okay, let's find the next one. So let me hold this a little bit closer because you have the steps. I don't know if that's okay. All right, so we're going to press second, trace. We're going to find the other 0. So now you're going to press the number 2. It says left. So what I want to do is I want to find this next intercept right here. I feel like I need to zoom in on this. I'm going to zoom in quick for you guys. Let's see. Perfect. Okay. So I found this one first. I want to find this one over here. So let's press second and then trace right here. Okay. Press the number 2, 2. So I want to find this one right here, that one right here. So I need to be on the left side of this point. So I'm going to move my little blinky dot. It'll come down. Come on. Oh, there it is. So I'm on the left side of this point, and so I'm going to press enter. Now it says go to the right side. So this is the right side of the point. I'm going to press enter. Take a guess. Yes. And here's your 0. 3.7. I'm going to round that to 3, 0. So there they are. And maximum value, again, you're doing those same steps for our maximum value. You're doing second trace and then number 3 for maximum, 3. Now we need to be on the left side. So the maximum's all the way up there. This is, what I'm going to do is I am actually going to zoom out so you can see where the maximum is. Sorry, this is you try to use the book. All right, so I zoomed out for you. All right, so second trace, 3 for maximum. Now it's going to say left bound. So you're going to have to be on the left side of this maximum point up here. So I'm on the left side. Enter. Now it's going to say go to the right side. So I go to the right side. I'm now on the right side of this maximum point. Enter. Take a guess. Yes. Maximum 3.48, 13.57. And I am just rounding to that nearest 100th point. And you found it. Here's the X and here's the Y. Again, this takes some practice. So you have to get used to going to the right of the point and going to the left of the point. And write down the domain and range for this situation. So let's label some things. This is the maximum point. 3.48, 13.57. Remember, DR. What do we notice? So first, let's look at the domain. This is the domain. This is the range. Domain. So for our domain, does it go towards the left? Does it go towards those negative numbers? Yes, it'll keep going towards those negative numbers. Or does it go towards the right? Does it go towards all those positive numbers? Yes. So for the domain, it's going to be X is all real numbers because it's going towards the negatives and going towards the positives. What do you notice about the range? That's right. The range has a maximum point. It is not going to be going higher than 13.57. It's not going to be going up here. Will it go lower? Will it go towards the negatives? Absolutely. But we know that our domain, actually I'm going to switch this to T. Sorry. T is in all real numbers. We know that the range, which is H of T, is always going to be less than or equal to 13.57. We're going to put some feet on that if you would like to. It won't go higher than that. So it'll be less than or equal to. And the reason why it's equal to is because that's where that max value was. Okay, this has been a little bit, video's been a little bit longer than I wanted. My graph was a little bit harder to see than I wanted it to be. Hopefully you hung in there. We'll try another problem in my class, and hopefully it helped those not in my class too. Thank you. This has been Piecewise Functions and Applications for Domain and Range.